Hello, good evening, everyone. Today we are having the Solve with Us session for week 6. So I hope you guys have covered the topics on week 6. Today we will solve the questions based on it. So first, please join the peer deck. Here is the password. Join it so that you can answer there whatever the questions we will discuss here. Keep your pen and paper ready. We will start the session, okay? Those who are joining late, for you, the password will be on the top right corner. Okay. So the first question is based on the joint PDF of two continuous random variable x and y, and one PDF is given to you, and you want to calculate the value for x. So will you proceed for it? So done.
Yes, ma'am.
Okay. So we have two continuous random variable here, x and y, which are continuous random variable. Okay. Okay. Anyone can tell me, like, we have seen joint PDF before also, right? Then what's the difference? Like, why are we again studying this joint PDF, and what new observation you might have observed here in this week 6 content? It's the same. We have studied joint PDF and marginal PDF. Now we are studying joint again, joint and PDF thing. What's the difference? Did you guys notice?
Ma'am, both the random variables are continuous.
Okay. And what before, like, we have studied this since before also, right?
Yes, ma'am. Those are
Ma'am,
discrete.
Those are
earlier
discrete.
in
Mm.
earlier in week 5 we have one random variable discrete and other one
Yeah, mixture also. Now
yeah.
we are having both as a continuous random variable. So uh, we have a like PDF is given to you fxy of this joint PDF. So k e to the power what minus x plus y, where x is greater or equal to 0 and y is also greater or equal to 0. So yes, start let's start how to solve to find out the value of k. So one thing we are studying from the starting only, that whatever the probabilities are there, if it is a pm probability mass function, probability distribution function, joint PDF of discrete or joint PDF of continuous random array, always it sums up to 1, right, when considered the
Yes, ma'am.
whole event.
Yes.
Yes,
So
ma'am.
Yes, ma'am.
in this particular case, how will you proceed? Like, do you know what are the possible values your fxy can take? See, x is greater or equal to 0. That means x can range from 0 to infinity. Y can take values from 0 to infinity. Then
Yes.
how will you proceed for this particular type of
And we
cases?
have to take double integration.
Yes, ma'am. I have
Okay.
to take double integration, or else you can do a graph.
Okay.
So we have to make a line like that. We have to take the area
Mm-hmm.
above the line that which is from x more than 0 and y more than 0. And if we find out the area
Mm-hmm.
which satisfy the condition, then we can find out the area.
Yeah. So, but here we want to find the value of k. So, like, how
Okay,
will you
yes.
proceed?
Then I have to double integrate equal to 1.
That means
Yes.
you are considering all the possible events, right? All the
Yes,
possibilities that
from 0 to
can
Yes,
infinity.
happen
ma'am.
for x when values of x and values of y can vary, right?
Yes, yes.
So
Yes,
we
yes,
say it
ma'am.
as a support of xy. What do you mean by support of xy?
It's simply a range, man.
Range,
Range.
range,
Yeah, a range of what?
X and Y.
Range of random variable.
Range of random variable x and y. Okay.
Yes.
So what will be here, like, what will be the integration limits for this particular one?
Uh, First one will be x
0
zero
to
equal to
infinity.
infinity. Second one will be y 0 equal to infinity.
0 to
Okay.
infinity, ma'am.
Okay. So whenever this kind of double integration is there, see, we have written dx plus. That means this inner integral sign is will have the limits for x, and this outer integral sign will represent the limits of y. ठीक?
Yes.
So so I'm representing here that y is equal to 0 to, yeah, infinity.
Mm. Mm.
Okay,
Yes,
and what about inner limit? X is equal to 0 to
0 to infinity.
infinity.
infinity. K into e to the power minus of x plus y
Mm.
dx dy.
Mm. Mm.
Okay, so now for those who may have seen this kind of double integration for the first time, then just don't afraid of it. Whenever this kind of situation is there, just forget about this. First consider this inner part only with
Yes.
first dx. Okay, at that
Mm-hmm.
time you will think, okay, I have to integrate like this, but what should I do with this y? At that time this y is not a variable for you. It's general a constant. It's a constant thing for you. Let's say x plus 3 or x plus 4 kind of things. Okay, so it will
Mm-hmm.
not disturb your integration. Now you know the integration of one variable, right? So Uh, Now I have k e to the power minus x plus y. So easiest way is to just common out your constant things so
Yes,
that you do
K
not
is
confuse
constant.
it.
K is constant.
And e to the power minus y also, right?
Yes.
Yes, ma'am.
I can write e to the power minus x plus y as e to the power minus x into e to the power minus y. Fine.
Mm-hmm.
Yes, ma'am.
That way I just common out e to the power minus y because I am considering y as a constant. So now my limit is from 0 to infinity e to the power minus x dx,
Mm.
which should be equal to 1. So yeah, then,
Then you have to integrate e to the minus x.
okay, just a minute. Aren't you guys able to join directly? Like, I have to give permission to
And
everyone.
first we integrate with the variable as x and constant as y. Then we integrate the whole for the dy.
Yeah. So k e to the power minus y. This is nothing but e to the power minus x by minus 1, right?
Mm-hmm.
Yes.
And limit you will apply is 0 to infinity.
Infinity.
Yeah,
Mm.
here dy is missing.
Mm.
Dy is equal to 1. Fine. So what now you put the limit, then e to the power minus infinity is what?
0,
And what about e to the power 0?
1.
1.
1.
So,
1.
so we will left with k e to the power minus y. This is nothing but 0 minus of 1,
1.
right?
Mm-hmm.
Yes, ma'am.
Dy, which is
Dy.
equal to 1.
Mm.
So, yeah, this is plus 1. So we left with the k e to the power minus y.
Mm-hmm.
Again, k common out and integral 0 to infinity e to the power minus y dy is equal to 1. Again, the same kind of integration. This will
Same,
leave
same.
you
Mm. So k will
k
be 1.
into 0 minus of 1,
Mm-hmm.
which is equal to 1. That implies your value for k is 1.
It's 1.
Okay. Is there any doubt for this
No, ma'am.
particular one?
No, ma'am.
Anyone else?
No, ma'am. No, ma'am.
Okay,
No, ma'am, clear.
fine. Is there anyone? Then just let me know. Okay,
No, ma'am.
fine.
Ma'am, what is the answer, ma'am?
K is 1. Yeah. Okay. So should we move to the next question?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So there is another like question related to the joint PDF of two continuous random variable x and y. The PDF is same, right? Now you know the value of k, and we have to find the probability that x is taking values greater or equal to 4 and y is taking values less or equal to 4.
Mm.
Ma'am,
So
please show the options.
yeah.
Please show the options once.
Yeah. Okay, so now we have a value for k is 1. So our PDF will become like xy is equal to e to the power minus x plus y, right? Where
Yes, ma'am.
x and
Yes,
y
ma'am.
both are greater or equal to 0.
Mm.
So, so there is not a much change, but whenever you want to calculate, want to find the probability that your x is taking values greater or equal to something, let's say value 4, and y is taking value less or equal to 4. At that time, this is nothing but what? Yeah, double integral of fxy of dx, right?
Yes, ma'am.
Yes, ma'am.
That's for sure. But where will we have changes then?
In the
In the limits.
limit,
Yeah,
ma'am.
Yes, ma'am. In the limits.
yeah. So,
Maybe
okay, what will be the limit for x and y?
X will be
Or x
4
will
to
be 4 to
infinity, 4
infinity.
to
4 to
infinity,
And
and Y will
y
be
is 0 to
minus
4.
infinity to 4.
Sorry, minus 4.
Sorry, minus infinity to 4 or 0 to 4?
No, 0 to 4. 0 to 4.
0 to
Why,
4.
why not
0 to
minus
4, 0 to 4.
infinity to 4?
Ma'am, the range defined is above 0.
It always takes
Yes.
positive, ma'am.
Equals to
If
0
it is
and greater.
Because of our support of x comma y.
Mm-hmm.
Support of x comma y is the collection of all the set of x comma y for which your PDF is non-zero, right?
Mm.
Non-zero and non-negative also, right?
Mm.
This is what the definition for support of x. So therefore, we have to take this as a what limit? Like a range of y should be from 4 to infinity. Sorry, 0 to infinity, right? Then it's nothing but just an integration kind of things. Oh, okay. Then yeah, first you will integrate with x, right?
Yes, ma'am.
Okay. Then what do you get there?
1 minute.
Y
E to
is
the power
from
minus
0 to
4.
4, and we will just integrate this one, keeping our e to the power, sorry, y as a constant. Fxy here in this particular case is e to the power minus x plus y, fine. So once you keep y as a constant, so I will common it out, and now you have to integrate e to the power minus x, which will give you e to the power minus x by minus 1, and your range is 4 to infinity. Fine. Okay. Then
Then we put limits.
yeah, just put limit. What will you get? E to the power minus infinity. That's 0
0.
minus e to the
4.
power minus 4 divided by minus
Minus.
1, right?
Minus
Yes.
1.
d. Okay. So now again, when I will integrate with respect to y, I just common out the things. So what will I get? E to the power minus 4 is common, and integral of e to the power minus y in the range 0 to 4, right?
Yes,
So
ma'am.
that is nothing but yeah, this one. Integral limit 0 to 4. Fine. So now you just put the limit, so you will get e to the power minus 4 divided by minus 1 minus, yeah. Then e to the power minus 0 is
1.
1. 1 upon minus 1, fine.
Yes, ma'am.
That's nothing but once you solve it, you will get e to the power minus 4, 1 minus e to the power minus 4, fine.
Yes, ma'am.
So that was the probability that x is taking value greater or equal to 4 and y is less or equal to 4, fine. So everything was just you have to define the limits of x
Ma'am,
and
can
y.
you please explain how it will give 1 minus e to the power minus 4 in the bracket?
This one?
Where it will? Yes, ma'am.
Okay. So see, once you decode the minus sign, this will be e to the power minus 4 as it is, okay? This outer side,
Yes,
inner
ma'am.
side.
And
What
here
will
will
this
be
divided by minus 1? So I can write it as a minus
minus
e to the power
e to the
minus
power
4, right?
minus 4 plus
And
1
what? Plus 1,
plus
yeah.
1.
That's it.
Okay, ma'am.
So I just switched it. Okay. Then,
Ma'am, sorry, can you please explain the limits, how we put the limits? I'm confused in that.
okay. See, we want our x should take the values greater or equal to 4, right? And y should take
Yes,
the values less or equal to 4.
right.
Now, for that, first just define your support of x set, support of x comma y. For this particular question, support of xy is what I just wrote here. Yeah, is the collection of all x comma y such that your fxy, that means your joint PDF, should be greater than 0. So just come here, just look at your PDF. For then, what will be the support of xy set will look like when you have joint PDF is like positive value whenever your x is greater than 0, greater or equal to 0, or y is greater or equal to 0, right?
Yes,
That
right.
means what will be the support of xy set if I want to write precisely? Then all the xy belonging to, yeah, R2, right? Such that x is greater or equal to 0 and y is also greater or equal to 0, right?
Yes, ma'am.
All the positive. Okay. Then out of this range, you want only those x for which values are greater or equal to 4, and y for which like y should be the value less or equal to 4 in this particular range. So here if I again decode it, then x will belong to what? 0 to infinity, right? And y will also belong to
0 to
0 to
infinity.
infinity. Fine. Now, can you give me what is the range for x greater or equal to 4 out of from this set?
4 to infinity.
Yeah, that means my range for x is
4 to infinity.
4 into, yeah, 4 to infinity. And what if I want y less or equal to 4 then,
0 to 4.
right? So the person who asked the question, did you clear how I got the limits?
Yes, ma'am, got it. Ma'am, just one more thing, because X and Y are such that, I mean, can we, I mean, can we replace switch the logic between these? Like, if I say X has to be less than equal to 4 and
Yeah.
Y should be greater than equal to 4,
Yes, yes,
right?
yes. You can find that probability also. If you want to calculate, you just can calculate probability that x is taking values less or equal to 4 and y is taking values greater or equal to 4.
So both will be same thing.
No, 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 no. Both will not be the same. May or may not be. Like it may be possible that if since in this particular question it's very symmetric kind of function, so it will give you the same answer, but not always. Why? Because if you have studied this double integral things, have you studied these things?
Yes, ma'am.
Then there are some rules and regulations for this double integral. Your function should be continuous and some
Ma'am, I have
rules.
a question.
Yeah.
Ma'am, there is a rule that means when we want to find the probability or f of x, then we have to integrate the y portion.
Yeah.
Isn't there a rule? So what is that? I mean, I'm a little bit confused about
That's
that.
marginal density.
So marginal density. Oh,
Yeah. Okay.
okay.
So if you want to calculate, just calculate it. I think in this particular question, you will get the same answer, but not always you will get the same answer. Okay. Are you guys calculating it? Just let me know what's the answer. Let's
Same
see.
answer, ma'am.
Yeah.
It gives same answer, ma'am.
Yeah, it will give, because this your e to the power minus x. See, I can write it like what? Your y limits are what? 4 to infinity, right? This is your y.
Yes.
And what will be your x? 0 to 4. And fxy is x plus y dx dy. So once you integrate it, it will give you 4 to infinity e to the power minus y common and e to the power minus x by minus 1 integral 0 to 4 dy. Fine. So this yeah, e to the power minus y again common out. So it's minus e to the power minus 4 minus plus, right? 3y. Now once you again integrate it, then you will get 1 minus e power minus 4 common, and integration of e power minus y give you minus 1 4 to infinity. So yeah, it's giving same answer, but in this particular question it's giving, but there you will find some question where this kind of things will not work. You have to check it. Have you studied that non-uniform distribution kind of impact?
Your voice is echoing.
Yeah, sorry.
Your voice was echoing.
Was it mine or someone else?
No, it's okay.
It's okay now.
Now it's okay.
Okay. So be careful. This will not be equal all the time. Right? Maybe sometimes. Okay. So yeah, this one is the solution there. So now there is another.
Ma'am,
Yeah.
ma'am, the answer was not equal, I think.
Is it so? Just let me check. No, it was same only, no?
Yes, ma'am. Same.
Did you get the
Yes, ma'am. It's
so just recheck your answer. Like, where did you get the difference one? Like, I don't think so. Yeah.
Okay, ma'am, I'll check.
The thing is, I just wrote e to the power minus y minus 4 there.
Ma'am, because I thought for the first it is e to the power 4 outside.
No, it was minus 4 only.
Okay, no problem, ma'am. We can proceed.
Okay.
Thank you.
So yeah, let's move to the another one. Here you have giant PDF of random variables x and y, and this is kind of conditional probability, right? We have to calculate probability x greater than 3/4, given that y is equal to 1/2.
Ma'am, these slides would be available online?
Yes, we'll post it on the portal.
Okay. Thank you.
Yeah.
Ma'am,
Yeah.
ma'am, should we put the value for y as 1 by 2 for Fy of I?
Fy of y.
Yeah, marginal density of I.
Yeah. Yes.
Okay. And ma'am,
First
in
Ma'am, for
calculate
the
marginal
for
and
the
then
yes, ma'am.
yeah.
For margin, we have to calculate now first.
First you have to calculate the marginal, then you
Yes, ma'am.
put the values.
Ma'am, for marginal, we have to integrate the x. I
From
think.
0 to half.
Integrate the joint PDF over the limits of x.
Yes, over the limit of
Zero
x.
to 1.
0 to 1.
Yeah.
Hmm. No, not 0 to 1, ma'am. I think it's 1 by half to 1. I think.
Check it.
ma'am, it is 0 to 1, right? For marginal density of I.
Yeah.
Ma'am, can you exceed time limit?
Yeah, sure. For marginal PDF, we integrate, for example, if we are calculating marginal PMF for y, then we will integrate it over the limits of x. All the possible values of x can take. So the limit will be from 0 to 1.
And my function will be 3x into half into 1 minus x, no?
It's a joint PDF, yeah.
Ma'am, in last two questions, also,
What?
ma'am, in
In
last two questions also we have taken the like you told that for the y we need to take for the limits of y if we are different integrating with respect to y we have to take the x limits. The same concept we did in last two questions also.
No, in the last question, we do not need to calculate the marginal PDF. When we are
Okay.
when we are going to calculate marginal PDF, at that time let's say if you are calculating marginal PDF for X, then you will
Yes.
allow Y to vary over all possible ranges it can have.
Okay, only for marginal
Yeah.
calculation, PDF calculation. So when we are calculating for X, then we need to take limits of Y.
Y, and if we are calculating PDF for Y, then integrate over Y. Sorry, integrate over X.
Okay, limits will be of X.
Yeah. So
Okay.
it's kind of similar. We have studied for the discrete when we were when we were calculating the marginal densities for discrete random variable. At the time also we were summing over. Like for example, if we are calculating marginal PDF for PMF for Y, then we were summing our joint PMF over the range of X.
Yes.
So here the summation is just replaced by integration because this is continuous random variable.
Okay.
So okay, done.
Yes.
Need extra time.
30 seconds.
Okay.
Yes, ma'am. Can you exceed?
Ma'am, for calculating the joint, what will be the ma'am range of Y? 1
Sorry.
upon 2 to infinity. Range of Y for calculating the joint.
No. Y will take at 1/2, right?
Yes,
For
ma'am.
Y, we'll take the value at a point 1/2.
We will put the value of Y in the given equation. The
Yes.
integrate over 3 upon 4 to infinity for joint, right, ma'am?
Hmm. Yeah.
Mom, I'm confused for this joint PDF. Is it not where Fy is 1 by 2? We have to further integrate with respect to x values 3 by 4 to 1.
And then?
Then 1 by 4 dx.
Okay. Let me discuss. Then if you have doubt there, then just clarify it, okay?
Okay.
So we have joint PDF here, right? Fxy of x comma y, which is given as, it was what? 3xy 1 minus x, right? 3xy times 1 minus x for the range. Yeah. The range for x is 0 to 1. And for y it is 0 to 2.
2.
And 0 otherwise. Fine. So do you guys know why we are calculating marginal PMF here?
Yes, ma'am. For the
Yes, ma'am.
conditional, we have joint upon marginal.
Okay. So once I have to calculate this conditional PMF, what the formula we have for the conditional
Probability of x greater than 3 upon 4. Intersection of probability of y is equal to half upon probability of y is equal to half.
So can I say it a joint PDF of x
Yes,
greater
ma'am, we
than
can.
3 by 4 and y
Yes,
is
ma'am,
equal
it
to
is.
1 by 2, right?
It is, yes.
Because we are dealing with the 2 random variable at a time, right?
Yes.
So this divided by marginal PDF at 1 by 2. Fine.
Mm.
So for
Yes.
this particular part, we are calculating marginal PDF. But once you calculate this one, then we have to find the like this one also. Integral for this x is taking greater values greater than 3/4 and y taking 1/2. Fine. So let's calculate first marginal PDF. So do you guys understand when I change my word, when I say PMF to PDF, why I'm doing that?
Yes.
So there is some sense, right?
Hmm.
Because your x and y are continuous random variable, you can't say it's a PMF, it's a PDF. Density function, not a mass function, okay? Fine. So marginal PDF for y, fy of y is what? You have to integrate your PDF function
0 to 1.
PDF, yeah, for the over the limits of x, whatever the limits of x are. Here it's from 0 to 1. Okay. Similarly, if you are calculating marginal PDF for x at that time, it's nothing but integral over y of the PDF function fxy. Okay. So at this time, when you are calculating marginal PDF for x, you have to integrate it over whole range of y. Okay. Let's say if there are 3 random variables x, y, and z, and I am asking you for the marginal PDF of x, then what will you do? If we
Then you have
have
to integrate
double integration of x
Yeah.
and z.
So yeah, I was just checking the understanding only. Yeah, if x, y, and z are random variable, you have joined PDF for x, y, z. Then how will you calculate marginal for x?
Double integration over y and z.
Over y and z. Fine.
Yes, ma'am.
Of what?
Of joint
Of
of
your
x, y, z.
joint PDF of x, y, z. dz, dy. Okay, or whatever the sequence is. Fine. So in this particular case, what do you get when you integrated it? It's what? 3xy 1 minus x.
We will put y is equal to half.
No, okay. First, just calculate in general, then you can put it on the last also. And if you want to put that 1/2 here, then just mention it. It is fy of 1/2, and then just apply it. Okay, 0 to 1, 3xy 1 minus x dx. Okay, can you integrate without putting the values y is equal to 1/2?
Ma'am,
Yes, ma'am.
that becomes so complicated for me, I think so.
Okay. See, it's not that much complicated in this
3y by
why?
2 minus y.
Because if you are not going like this, then you can do one thing here. Whatever the constant is, just keep it outside. So you will you just keep it outside 3y, because y you treat as a constant when you don't know the values of, when you are integrating over x. Okay. So just keep it outside and integrate the remaining thing 0 to 1 x into 1 minus x dx. Okay.
Okay.
So this is one of the way to calculate the margin. Okay, but in this particular case we need fy of 1/2, so we can do that. Okay. Then what did you get for the integration? 3/2 integral of x minus x squared dx. Fine. 0 to 1.
We have to split the integration.
Split by integration means? Okay, this
Means
over
split
addition
on,
or
yes,
subtraction.
ma'am. Subtraction, ma'am.
So what's your integration for x? It's x square
X
by 2
square upon 2,
minus for x
X
square
cube by
integration.
3.
Yeah,
X cube
x
by
x cube upon 3.
and the limits are 0 to 1. Fine. Okay, for 0 it's obviously 0, and when you put 1
1
it's
upon 2 minus
minus
1
1 by
upon
3.
3.
Okay, then
3/12.
3 minus 1. Okay, it's a 1/6.
Yes, ma'am.
Okay. So it's
1
1
by
by
4.
4. Okay. This is your Fy
Yes,
of
ma'am.
1 by 2. Okay. Now you want one more thing to calculate your conditional
Joint.
PDF. That's a joint PDF of x greater than 3 by 4 and y is equal to 1 by 2. So f of x taking values greater than 3 by 4 and y taking values 1 by 2. How will you proceed for it?
Double integration.
Just, yeah. Double integration, but how will you put the values for y then?
3 by 4 to 1 for x
Okay, x is equal to 3 by 4 to 1.
and 1 by 2 to 2 for y, ma'am.
But when you take the limit 1 by 2 to 2 for the y, at that time you are considering this whole area, which is not required here.
Yes, yes, yes.
Ma'am,
Y is
it
not
is just it is just marginal when x is between 3 by 4 between 3 by 4 and 1, ma'am.
So, but okay, if it is a
Yes, ma'am, even
marginal,
I think it's not.
Means, or you have to just integrate the x part and multiply the marginal part of Fy.
can you please repeat? I
Means
don't
if we
think so it's
just
making sense. Yeah, please repeat.
means if we just integrate the x portion and if we just simply multiply the marginal of y, then could it be the same answer?
No.
We can just give y as 1 by 2, substitute that value, and then we can integrate x.
Yes, the same thing as we did here. See, here we also have calculated marginal PDF for y, and we put the value of y as 1 by 2.
X.
Okay, so the same thing we can do here. Instead of this y, we will replace it with the what the value we want is 1 by
1
2.
by
Right?
2.
Yeah. So it's 1 by 2 here. Fine. And then just integrate it. That will give you the this joint PDF here.
But at point, at y is equal to 1 by 2, will not it be 0?
No, it will not. I think you are confusing it with a single random variable.
We are considering around 1 by 2.
Yeah, but whenever, see, if you can you just plot this in terms of graph these values only. So continuous random variable will give you the probability as a 0 when you are talking about it a single point. But let's say your 3 by 4 x is equal to 3 by 4 is somewhere here, okay? And let's say y is equal to 1 by 2 is here, right? So they are saying your y is equal to 1 by 2. You are calculating the joint PDF at this along this line y is equal to 1 by 2 and x greater or equal to 3 by 4. That means what is
then
your,
it will be a line, not a point.
yeah, this whole line will be your,
Okay, got it.
that's why it will not become a 0 and you can do like that, okay?
Ma'am, in place of equal to y equal to half, if there would be y greater than equal to half, then what would be the probability or answer?
Sorry, y greater or equal to 1 by 2?
If there is a notation like y greater than equal to 1 by 2, in that case, what we have to do? Instead
You
of
have to integrate from 1 by 2 to like your range of y. You have to integrate in that time a double integral. The range of x will be 3 by 4 to 1 and range of y will be 1 by 2 to infinity. Infinity, not here 2 only.
But in that case, we cannot put the value of y in that equation. Na?
Yeah, so we will integrate. No. So in that case, you will have your integration as y, you told greater than 1 by 2, right?
Yes.
1 by 2 to sorry, the upper limit is 2.
2.
And x you will integrate from 3 by 4 to 1. Whenever it's a single point, you can directly put that value on the
It's
required
for marginal. It's for marginal.
It's not a marginal. It's a joint PDF. See,
No, I'm
what's
just
the
talking about
difference
the
between?
marginal, ma'am. If there is given that y is greater than equal to half, so in that case, how will you find the marginal?
So you want to calculate this probability on y greater or equal to 1 by 2. Is it so?
No. If it is the marginal, means f of means small f y greater than equal to half.
Y greater or equal to half.
Yes. If that would be the condition given in that case, in conditional probability, that is the condition, then how you could find the
Okay,
marginal
fine.
in that case?
Fine. So in that case, first you have to calculate fi of y, okay? That you can calculate easily, right? For example, in this particular question also, we have, this is nothing but what? 3 by 2, 3 by 2. Yeah. Fine. So whenever you have this kind of marginal PDF, first, one more thing. Whenever you talk about the marginal things, for example, marginal PDF of y at a point, then we ask the probability generally at a point, not at over the range. That's why it's a marginal one, because we want to calculate the probability of y taking this particular value. So I don't think so, like how to go with this y greater or equal to 1 by 2. So let's try it. What's f of fy of y in this particular case, by the way? 3xy 1 minus x, right? 0 to 1, 3xy 1 minus x dx, fine? So just common out your y, and you will left with 0 to 1, 3x 1 minus x dx, right? And that's nothing but 3y x square by 2 minus x cube by 3 over to 1. So it's a 3y.
Y by 2.
Yeah. Sorry, what do you get? Y by 2.
Yes, ma'am. 3y by
3y
into
by
1 by 6.
Yeah, 3y by 6. So it's a y by 2. Okay.
Y by 2.
You got fy of y as equal to y by 2. Now you are asking me the probability that y is greater or equal to what? Some value 1 by 2.
Half, yes.
Okay. Then I think you can also answer it.
Yes.
See, now you have your marginal, this one, right? Let's say this is not a, for just time being, just consider it, it's not a continuous random variable, it's a discrete.
Okay.
At that time, your y is taking value, let's say 1, 2, and 3, and I am asking you what's the marginal PDF for y taking values greater or equal to 2. Then what will you do?
Then I will simply go for the x means 2, 3. I will take the range from 2, 3, and so on.
No, if it is a discrete, then you just add all this marginal, no?
Yes.
Fi
I'm
of
saying
2
that
plus fi of
2
3,
and
right?
3. Yes.
So here the same thing we replace it by with the
Integration.
Ma'am.
Then what will be your integration? Just a minute. Okay. Then fy of y greater or equal to 1 by 2, what will you integrate and what will be your limits?
1 by 2.
1 y, this is y or x?
X, it will be x.
This is x.
Will be x? Are you sure?
Yes.
You have calculated x, calculate the marginal PDF already, varying x. So now no need to keep the limits of x. That's why I'm asking you precisely what are you integrating and over which point. So now you have only one variable, that is y, and you want to sum up over all the values of y which are taking values greater or equal to 1 by 2.
Oh,
right?
Means in this case, I would don't need to take the value between x.
Yeah, because now you want to see this integration is nothing but the summation only. I'm telling this line again and again from the last 2-3 lectures.
Yes,
because these integrations are nothing but the summations, but with the small portions. Now, when you say your y is taking all the points lying between 1 by 2 to 2, so there are uncountable points, right? So uncountable sum is not possible. So we will do the integration from 1 by 2 to 2, and that will be the value of y only, because see, when I say your y is taking 2, 3, 4 and 5 only, let's say, at that time I will sum up over what? Was this the value of y or x? So these were the value of
Y.
y only, right?
Y only,
So
yes.
I summed up the values of marginal PMF over the values of y. So what should I do when it comes to integration? I have to integrate over the y, but what will be my integrand here?
Y by 2.
Integrated, yeah, fy of y. If I want to be precise,
Y,
I
Y.
will say fy of y dy, right?
Dy, yes, yes, yes.
Okay.
Okay, ma'am.
So it will be y by 1 by 2 to 2, your y by 2 dy.
Okay, I got it.
Okay, fine.
Yes.
So fine. So this was another question. Let's come back to here. So here your fxy, x was greater or equal to 3 by 4 and y is equal to 1 by 2. So in this kind of questions, whenever you have at a particular point, we want to calculate the joint PDF, we will just do one thing. We will put the values of x or y, whatever that is the particular point is, okay?
Okay.
Fine. Just a minute. Okay. So now, how to proceed with this? Yeah, how to just integrate,
Just
right?
take,
This is
just
3
take
by
limit
2.
3 by 2. No, 3 by 4
Mm-hmm.
to 1.
And
Integrate
like
that function.
yes, yeah. So when we were like, just a minute, when we were discussing this, someone was asking some question. Is it clear to you, or if not, then please tell me.
Yes.
Okay. Okay. So just integrate it and put the values. So what did you get? Can you tell me the answer?
Ma'am, I got 5 upon 128.
Okay. So once you go for the calculation, first put the values for 1. So it's a 1 by 2 minus 1 by 3. Right?
Yes, ma'am.
Minus of
9 upon 32.
You can do this kind of things if you are not
Yes, ma'am.
comfortable with negative signs. So first put
Yes,
3
ma'am.
by 4. So it's a 9 by
9
32
upon 32 minus 9, 9
minus
upon 64.
27 by
9 upon 64, ma'am. After
64 into
simplifying.
3, right?
After simplifying 27
Yeah,
upon
64.
Yes, ma'am. Ma'am, 9 upon
Yeah.
64 will be there.
Yeah, because this 3 will get cancelled here.
Yes, ma'am. Yes, ma'am.
So just now calculation part only. This is 1 by 6, fine. This part minus this is what 9 by 16. Sorry, yeah, 9 by 64. Then
9 upon 64 we will get
9 by 32 minus 9 by 64. Yeah, 9 by 64.
64.
Yeah. Then the final will be, is it 5 by 32?
Ma'am, 5 upon 128.
You got 128.
Yes, ma'am. And after doing this, the subtraction in between, we got 5 upon 192.
Just a minute. Okay. This is what 3 by 2 and 64. So, okay, just a minute, wait. We have one more thing here, right? Before simplifying it, my suggestion is just take this under consideration. We are calculating what? fxy, x is greater than 3 by 4 and y is taking value greater than, y is taking value equal to 2, right?
1 by 2.
2 1 by 2, sorry. And we are finding the probability that x is greater than 3 by 4 given that y is equal to 1 by 2. So for that we need this joint PDF divided by our marginal. So if calculation can be easy using that. So just put that value. What was fy of 1 by 2? It was some 1 by 4, right?
4.
Yes, ma'am. 1
So
by
this is nothing but what? 4 times can I write? See, 3 by 2, 1 by 6 minus. Okay. 3 by 2, 1 by 6 minus 9 by what? 64 divided by 4. Okay. So once you, sorry, 1 by 4. Is it 1 by 4, right? So it just 4 will go up and it will be a 9 by 64. Yeah. After simplifying, what did you get?
5 upon 32.
6 1 by 6 minus 9 by 64. See, it became somewhat relatable, right? So now nothing but 1 minus 6 into 9. So you can have 327 by what? 32. Yeah, so it's a 5 by 32. Fine. Did you guys got this
Yes,
answer?
Yes, ma'am. 5 by 34 I got.
So yeah, sometimes whenever the calculation like looks like this much tricky, just put your whatever the second value denominator is coming there, and things may be easy, like time saving. Okay, so this was your conditional probability when x was taking the values greater than 3 by 4 and y was taking value 1 by 2. So any doubt here?
No, ma'am.
Okay.
Ma'am,
Yeah.
ma'am, I have another doubt. Like,
Yeah.
if we have a range where x is, let's say, greater or less than y.
Greater or? Okay.
Less than maybe.
Let's say greater or equal to y. Okay.
We have to find p of that.
Probability of this things.
Yes.
Okay. So whenever this kind of things are there, you have to grow with the graph kind of things.
Yeah.
Because then whenever this kind of things are there, x is greater or equal to y, at that time, you will have equation of line or equation of curve. Okay. So your range of x, let's say this is your graph. Let's say simply rectangle or not rectangle, this kind of thing, something like that. And you want x should be always greater or equal to y kind of things. In that case, we deal with this, like say x is greater or equal to y, then that means you just plot the line for x is equal to y. Okay, then find the region where the values will be greater or equal to y. So in this particular, by observing this graph, can you just tell me which part is your x is greater or equal to y part? This is your graph. This is x is equal to y line. Then can you find what is the which one is the region for which x is greater or equal to y?
Ma'am, the
upper one or lower one?
Lower one.
Lower one.
How do you check this? How do you check this?
And we can take any point from that and then check if x is.
That's a simple thing. You just put any point and check whether that point is following that rule or not. We know that this is Cartesian plot, so every point is x comma y format. Let's say here the point will be something like around 3 comma 1, right? So yeah, it's following that. Okay. Generally, the best part is to look at the your coordinate axis, this axis, along the axis. Whenever you pass over this axis, your x will take the non-zero values and in positive way, and your y is 0. So in this part, your y is always less or equal to, sorry, y part is less or equal to x. So this is the region. Okay. So now you want to calculate probability that x is greater or equal to y. That means you have to find the probability that your x and y are lying on this region. So that is nothing but the area of this region. Okay. Do you know how to calculate the area of this kind of things?
Yes, ma'am.
If it is a triangle and rectangle, then it's easy. But let's say if it is not a triangle or rectangle, then
Ma'am, we have to
Integration in the brain.
double integral. Okay, you have to take any strip. Let's say this is my strip. And if this is the strip, then what will be the equation? This will be my lower limit for what? And this will be upper limit for what? And what will you run? So if you are
And
taking
lower limit for what?
Yeah, this is lower limit of what?
X.
X.
Yeah, this will be the lower limit of x, and this will be a upper limit of x. And
Yes.
you will integrate it over from 0 to whatever the value that y has here, right? Okay. And similarly, if someone says, okay, don't take the horizontal one, take the vertical one at that time.
Limit changes for y.
Limit changes for y, yeah. But in this case, we will not prefer for the vertical line, because then in that case, you have to separate this in two parts again, this part and this part. Separately, you have to calculate, because the equation of y is changing due to this line and this line. Okay. Okay. So in this way, you can calculate x probability of x greater or equal to y. Okay, did you get it?
If can't we use the integral formula and define the limits, like
what?
Like let's say it's a uniform distribution 1/3. So and the same condition was there that x is greater than y. So can't we have the limits by simple formula? We cannot do that. We have to approach using the diagram.
What formula, right?
Like
I'm
the
asking
double
that.
integral part. Let's say x and y both are defined between 0 to 1, and something 1/3 has come out. But I want the probability where x is greater than y. So how to approach that? Can't we have this formula like double integral where x is greater than y? So I should take something 0 to x for dy, and then 0 to 1 for dx.
No,
if
actually.
I'm making any sense.
No. See, what you are asking, I'm getting it. But see, the thing is, whenever this kind of thing is there, it's necessary to have a figure like this, because, for example, in this particular question only, if someone by mistake take the vertical strip, okay, let me change the color. So let's say someone is taking the vertical strip like this, and vertical strip like this one, then this strip will change its values. Its values will be like y is equal to 0 to y is equal to x, right? These are the limits for y till this point. This one, which I have marked with this plus sign. Okay. Till this line, whenever this strip will move from this to this part, that's fine. But once your strip reach to x is equal to a, after that, your upper limit for y is no more y is equal to x, right?
Yes,
It may be some y is equal to minus x, this line, equation of this line. So if you go directly with the values, what you have, numerical values, at that time, this will create a problem. So to avoid this kind of problem, we draw the figure and find out whether there is any break or not. So this kind of situation may appear and your answer will be wrong, because in that case you will integrate it over for y is equal to x only, and integrate till x is equal to, let's say, 1 here. Then you will calculate this extra part. Are you getting me?
Yeah.
Like if you continue with y is equal to 0 to x, for x ranging from 0 to 1, you are calculating this extra part also. So in that case, you will end with the wrong answer. So better practice is to go with the figure.
But then again, it will limit me with uniform distribution mostly, or something which can be drawn. What about normal distribution and exponential distribution? For that, if such conditions are given, that find the probability where f x is greater than y, then it's become difficult to draw, no?
In that case, you know the equation of curve directly, right? And you know that there is no breakage kind of things. If you know the distribution, at that time you can have this kind of things. But this particular example which I drawn here, that is not a kind of well-known distribution, right? In that case, you have to go with the figure. If you know that your distribution for the random variable is following some particular well-known distribution, then you can directly jump for the formula.
Ma'am, this function is not continuous because of sharp edge.
Because of?
Sharp edge.
That's for the curve.
And there is a sharp edge.
For curve, like, just a minute. That's fine. But our area of region is this red colored part is there, no? That's our area. And you are talking about this point. Because of the sharp edge, the graph is not continuous. That's wrong. Because of the sharp edge, it's not differentiable at that point. Okay?
Yes.
Continuity cannot be restricted with the sharp edges.
Mm-hmm.
Like, will you say that mod x is a not continuous function?
It's a continuous, but not in a differentiable.
But it has a sharp edge at 0.
Mm-hmm.
Yes,
we have read it in math 1 also. This kind of thing.
So it's a continuous on R, but not differentiable
Not
on R.
differentiable. Yes.
Okay.
Right? So the differentiability, but we can say that it's a differentiable on 0 to infinity or negative infinity to 0. Is it so?
Yes, ma'am.
Because there is no sharp edge when you discard your 0 or discard your one part due to which sharp edge is created.
Ma'am, by seeing a graph, how could we recognize that it is independent or not?
By seeing the graph.
Is it possible?
By seeing the graph will take time. Like it's possible, but you have to first calculate and verify. But directly to, I don't think so.
Okay.
Okay, so let's move to the next question. Is this clear to everyone? Is this question? Yeah. Yes.
Ma'am, I still have doubt in that part.
Okay, just a minute.
Back to that screen.
Yeah. Yes.
Ma'am, your screen is there.
Isn't it visible?
Yes, now it is visible. Ma'am, please show the graph once.
Yeah.
Ma'am, you said
So
that we have to double integrate with the range of x. Ma'am, you said that we have to double integrate with the range of x.
With the range of x?
Like a joint.
See, when it's a double integration, then you have to integrate for the range x and for the range y both.
Yes, ma'am.
Okay. Whenever there is a double integration, you have to integrate it for the both of the variables.
Both of the variables with lower limit with respect to x and upper limit also with respect to x.
No.
This
It's
example.
a double integration kind of things, like surface integral. Have you studied the surface integral part?
Ma'am, if you can tell a bit, I'll be able to.
Sorry.
Ma'am, not able to recall currently.
Okay. See, double integral. Let's say this is some. Let's say y is equal to f of x. Is it fine for you guys? If I
Yes, it's
say y is
PDF.
equal to f of x, not PDF. This is a general of function. I am just talking about surface integral.
Okay.
Yes, ma'am.
And this is let's say x is equal to 4. Is it fine? Now
Yes, ma'am.
you have x is limit for x is equal to 0 to 4, and I am asking you to find the area under this curve. How will you calculate it? Yeah, anyone can answer.
Integral 0 to 4 f of
Integral
x.
0.
Yeah, integral 0 to 4 and then
fx dx.
integral 0 to 4 fx dx.
Yes, ma'am.
Okay, is it
Yes,
fine?
ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
Okay. And if I ask you, I want to calculate, let's say this is the PDF of some function, some random variable x and y. Let's say y is equal to some h of x, and you have to calculate the this one, double integral fxy. You are just checking whether it's a valid PDF or not, dx dy. Okay, that means you have to double, and you know that the equation y is equal to h of x, and this is your what? Sorry, PDF distribution. Fine. Then how will you go with that?
Ma'am, y limit will go from
Let's
like
say
0
y is
to
equal
h
to
inverse of.
something. Sorry, I cannot hear you. What were you saying?
I was saying that in that case, y limit will go from 0 to the function inverse of that function. We can say if it is hx. So
Let's say
h
it's
inverse
h
of
only, okay? Which is a function of x. Let's say some x square plus x cube kind of things. I'm just taking it, okay? X square plus x kind of thing may or may not look like that, okay? Plus k. In that case, or the simplest way is to take the hyperbola. That will like be easiest form to understand. Let's say this kind of thing is there, okay? This is some y is equal to 4x square is there, okay? And this is your x is equal to 4, and we want to find the PDF under this region. Then what will you do? You know that your x is ranging from 0 to 4. So you will take the strip.
Yes.
Okay. Now, the thing is, in surface integral, whenever we calculate this kind of double integration, at that time, we just consider it as a strip, okay? Or one rod, which you start sweeping from this point, x is equal to 0, then you will swipe it in this direction, okay? Okay?
Yes.
So, just tell me, if you swipe this strip from x is equal to 0 to x is equal to 4, then will it cover this shaded region?
Yes, ma'am.
No, ma'am. No, ma'am.
Why
No,
not?
ma'am. We are
Why not?
because we are not taking y.
Below the curve, the area is not even.
Because y is changing at every point.
Exactly. That's why what we will do, we will define the upper limit of this rod. Let's say the lower limit, like length of the rod will be y is equal to 0 to y is equal to 4x square, okay?
Yes.
So when my strip is here, y is equal to will be 4x square. That means it will put x as equal to 0. So the length of rod will be 0. Fine, because there is nothing at x is equal to 0, y is equal to 0. Let's say my rod is at, let's say this is x is equal to a. At that time, my length of rod will get adjusted at 4a square. Fine. So
Yes, ma'am.
now with this, I have just defined the length of rod, upper length of rod as a 4x square. So once I move in the direction of x, my length of rod will get changed. And now if I ask, if I swipe this rod from x is equal to x is equal to 4, will it cover the shaded region?
Yes, ma'am.
Okay. So that was the answer to that girl what you asked here. So what should be the limit for this kind of integration? So your x will range from 0 to 4, start from 0 to 4, and y will be from 0 to 4x square. But generally we do one thing, whenever this constant kind of limits are there, we put them at outside so that at the end you will get the final answer.
Ma'am,
Yeah.
I'm not get this one, ma'am. If we put vertical strip, then why we don't get the shaded region?
Because your length, let's say, if the length of rod is fixed, let's say 2 centimeters someone has fixed, but when you reach to this point, the length of rod is this much only. Fine.
Oh,
How
okay,
will you
okay,
cover
okay.
this portion? So that's why I have to fix my upper limit, upper length of the rod. Okay. That's the reason behind whenever we define the strip like that, we always define its lower limit and upper limit in terms of another variable, because we are changing, varying this another variable. Okay.
Okay.
So is it clear your doubt? Who asked that
Yes,
question?
ma'am.
Ma'am, last point you are explaining, ma'am. Last.
Sorry?
Sweeping this integration for
Okay.
last point you are explaining that you have taken the limit from x to 4, x equal to 0 to 4,
4.
and y
Okay.
0 to 4x square,
Yeah.
and then you interchange it.
Yeah. Then I will swipe it from x is equal to 0 to, let's say, all the points I will cover. Like I will travel travel along this line, no? Because x is equal to 4 is in this direction, right? So I will move my this strip from this part to then this part to then this part, and I will cover the whole shaded area.
No, not that one. No. Interchanging this integration.
Okay, you
Final
want the
stage.
change of
Yes.
limits part thing.
You change no because our final this constant should be outside.
Okay, okay.
And
Here
that
only.
that
Okay.
part.
Okay. For that, there is one rule that your fxy should be continuous. Once it's a continuous, if possible, then we just put y as a constant form. Okay, y in constant limits, and x in the varying field. X in the varying limits. Okay, varying limits means this kind of 4x square, or sometimes 2x or 3x, this kind of stuffs.
So this
Not,
varying limit should always be inside.
yeah, because you just see, if I integrate, let's forget about this thing. If I am giving you to integrate this, let's say some 0 to 1 integral, and this is my x values, and integral is y is equal to 0 to y is equal to 4x square, the same question. Okay, and I'm asking you to integrate it along x dy dx. Okay, will you just calculate it? What will it give you? This is not a tough task. Okay, see, so once you integrate it, y is equal to 0 to 4x square, what will you get? It is integral 0 to 1, and it's the integration. Yeah, so it's a x outside, and y is 0 to 4x square, right? Dx, right? Because you are integrating x with respect to y. So x is constant here, right? Are you getting it?
Yes, ma'am.
Yes.
Okay. So here integral 0 to 1 x into 4x square dx. Now you just integrate it. What will you get? 4x to the power 4 by 4. That is nothing but 1, right? Integral 0 to 1. So your answer is 1, right? For this particular integral, let's say I1. Okay. Now I am asking you to the same question, but it will not remain same now. Once I change the limit for y is equal to 0 to 4x square outside and integral 0 to 1 x dx, right? Once I am taking the limits here, so I have to integrate over with respect to x only, right? Now integrate it and check whether your answers are same or not. See, what will you get? 0 to 4x square, integrate x dx over the 0 to 1. What will you get? It's
1 by
x
2.
square by 2. Yeah. And then what do you left with? 1 by 2 only, right? dy. You just again integrate it and you will get 4x square by 2, right? As a final answer. 1 by 2 outside and integral dy is y. Take the upper limits and lower limits. You'll just put it, you will get 1 by 2 4x square, right? So it's a twice x square. So your answer is in terms of twice x square, right? Now did you get the I1 and I2 are almost same, x dy dx or x dx dy, and x is also continuous, but still once you replace the limits, it's not working. They are not giving the same answer, right? Even though you had the limits of x, but still you are getting the values answers in terms of x. So there are some rules actually. These are we say it as a double integral kind of things. Whenever this kind of situation is there, this kind of situations appears there, we go with the change of integration kind of things. This is one of the thing you can search, and if you are interested to learn about this, you can search this change of integration kind of things, and we'll get to know that how that works, and you can interchange these limits. Okay.
Yes, ma'am. Thank you.
These are some different things, but this is the point. This is the language you can search with and get the forms. Okay. Okay.
Ma'am, whenever we are taking a strip, should
Okay.
it be always, perpendicular to the curve?
Perpendicular to the curve.
Like,
You can't say the perpendicular, but it will, we say it like that. It touches like curve. Should be like that.
like
Then
the
only
upper limit of the strip should always touch the curve. So it can't
upper
be.
or lower. But since we are studying the probabilities, so probabilities generally take the positive 0 to 1 values, right? So that's why in maximum of these kind of cases, you will get the upper limit as a very like equation of curve kind of things.
Okay, thank you.
Okay. So you guys have not studied ever this double integral kind of things? Anyone?
We had, ma'am.
Yes,
Okay.
ma'am. I've studied in class 12.
Okay.
Ma'am, what, ma'am? Can you please again tell?
Double integrals.
Yes, ma'am.
So whatever we were discussing till now, that was double integral stuff. So I hope it may have clarified somewhat, but that's actually one of the topics in mathematics. If you are interested, you can search and learn that kind of things. Okay, let's come back to our session. So the question is, the amount of milk in a shop at the beginning of any random day, any day is a random amount x from which the random amount y is sold during that day. Okay. Assume that the joint density function of x and y is given like that. Find the probability that amount of milk left at the end of the day is less than 2 liters. Do you understand the question?
No, ma'am.
Yes,
Can you
ma'am.
please explain again?
Yeah. See, your x is a random variable, which is denoting amount of milk on any day, on beginning of the day. Okay. And y is a random variable, which is denoting amount of milk sold during that day. Okay. So what will you get if I subtract x minus y?
The amount left.
Uh, x minus y equal to 50, I think.
Not 50. I am not asking the answer. I am asking
Milk
what
not
will,
sold, ma'am.
yeah,
The
milk
amount left.
remain. Yeah. Okay. So that's the question. Find the probability that amount of milk left at the end of the day is less than 2 liters. So I gave you hint x minus y.
Yes,
Yes, x minus y less than equal to 2
Then equal to
liters.
2.
Yeah. So just go ahead. Okay, this is the kind of question we were discussing till now. Why x less or equal to y you were asking. Here y is less or equal to x.
Ma'am, is this a last question or anyone?
No, this is not.
Okay, ma'am.
But see, as we have discussion over this x less or equal to y thing, I think you guys can do this question now.
Ma'am,
Yeah.
ma'am, is it x minus y less than 2 or less than equal to 2?
Less than 2 liters, right? We want.
Strictly
Then,
less, right?
yeah.
Less than 2, I think. Less than 2.
Yes. So just tell me what will be your first step?
Yes, first I think we have to
First
find
we'll
out the
integrate.
area of support.
Support you know, right?
Yes, support I know.
Then what will be your next step? Okay, first is support. Support you know. Okay, then what?
Support is I think 25.
Is it support? Support of x comma y is the range of random variables that can attain, right? It's the values that random variable takes.
0 to 5, na?
We'll
This
integrate
is
y from 0
two
to.
variable things, so you can't say it's just 0 to 5.
Ma'am, can you increase the time?
Yeah, sure.
And we will make first diagram.
Yeah, that is the first one.
Support I think is 2, I think.
Sorry?
Support is 2, I think. 2. Support.
Support is not 2. Support is a set of all the values of x
No, means
comma y.
I am not telling. Means the
No.
actually
Support.
here the support is not the area. Means area of x and y.
No. Support is, see, support is never an area. It's always a set of points.
Okay.
It's a set of points for which your PDF will take non-zero values, non-zero and positive. Did you get me?
Yes, ma'am.
Ma'am, support of y is greater than x plus x minus 2.
Is it so? If you ask me support of x comma y,
Or support of x is less than 2 plus y.
support of let's say x comma y in this particular example, then it will be always points x comma y belonging from what? R cross R, right?
Yes.
Such that your PDF x comma y will take a positive values on it. So in this particular case, whenever what are the points for which this is taking positive values? Yeah, that is, yeah,
Ma'am, can you do this by drawing a graph?
that is the only thing you have to do.
203040.
That are, if you give like 2 0
Area under y equal
and
to
all
x.
these things, then you will just end up with the countable numbers. But see, whenever your x and y are coming from the R cross R, and x is belonging from what, 0 to 5, right?
Yes, 0 to 5.
Then
Yes, ma'am.
obviously this set has countability as a So now how will you draw the graph for this particular thing? So let's start.
Yes, ma'am. First, we have to take from 0 to 10 in x-axis.
Why 10?
Sorry, means 5.
0 to 4.
Let's say this is 5, okay? Why?
5 and in x also 5. Even x also 5.
Okay.
Yes.
This is, sorry, this is 5.
5.
Ma'am, can you show me the function, ma'am?
Yeah.
You can go, ma'am. Go ahead.
Okay. Please write this function. And I am also increasing the time. Okay. So the first thing we know about the function is, let's say fxy is what?
2 by 25.
Something 2 by 25. Y is equal to, so 2 by 25. Whenever your x was lying between 0 to 5.
5.
And
Y also same.
not same, it's a lesser, okay? 0 otherwise. See, once I write y is lying between 0 to 5 and x is lying 0 to 5, then my graph will be this one only. That's it.
Yes.
But now, in this particular case, it's not like that. I want my y should be always less or equal to x. So what I will do, I will just draw the y is equal to x line, which is nothing but this one, right?
On diagonal line. Yes.
Yeah. Y is equal to x. Now my required area is x is lying between 0 to 5 and y should be less or equal to x. So which region, upper or lower?
Lower region.
Okay, and
yes, ma'am, yes.
x is this one, so I can write it now. So my required region is this one.
Yes, ma'am.
Okay, let's say this one. This all.
So, ma'am, if we find out the total area and the required area, so we can just simply find out the probability by the required probability by the total area.
Yeah, required area divided by
total
area.
Total area. Yes, yes.
Yeah, that will be your final one. So let's name these things because this is somewhat going to be tricky. So let's name it as O, A, and B. Fine.
Yes, ma'am.
So can anyone tell me what this area of triangle OAB will give me? Like
25 by
will it integrate?
25 by 2.
But so okay.
Area means triangle formula area.
Area of triangle OAB is what?
Half into base into height. Half into 5 into 5.
Half into
height. Okay.
That
5 into 5.
So I can have it 5 into 5. Okay.
25 by 2.
So that is my 25 by 2.
Yes, ma'am.
Once I know the area of triangle OAB, I also know what is my PDF, right? PDF is nothing but the 1 upon area of this D. Right?
Yes,
you
ma'am.
might have studied this. So you can recheck it. It's 2 by 25, right?
If it's uniform, I think.
Yeah, it's a uniform.
If you know. Ma'am, is it uniform? Is it a uniform?
Yeah.
How is it uniform?
By just observing this, the next step is this only. There's that as the area of this triangle OAB is 25 by 2, and also from the given, we know that your fxy is nothing but 1 upon the area of triangle OAB. That imply your joint PDF is uniform in the given support.
Okay. Okay.
Okay.
Okay.
And since it
Okay.
is given that your fxy is 2 by 25, which is equal to 1 upon area of, or you can understand, right?
Yes. Yes.
Okay. So that implies what? Fxy is uniform. Uniform in which region?
Ma'am,
Yeah.
when to calculate area of triangle? Because earlier we did not calculated the triangle area of triangle, right?
Which earlier means before this
Previous
week
question.
continues.
Previous questions.
Because there we did not like it was not needed there. But see here, this was not the requirement. The requirement is we want to calculate what? Probability that your subtraction x minus y should be strictly less than 2, right? You want to get this answer, right?
Yes, ma'am.
For this, you have to go with the figure only. So let's take what is the region where your x minus y will be less than 2. Yeah.
Sorry to interrupt you.
Yeah.
But it will be y greater than 2 is the... We have to calculate y is greater than 2, right?
Why y greater than 2 always? If your x is equal to 0, then y, okay. Y equal to 2 will not work. Okay, y greater than 2. But that's not the only thing. No? If you're, let's say, y is equal to 3 and you are taking x is equal to 2, then subtraction is what? Minus 1. Will it work?
Okay. Okay.
So,
But they have the limit of x will be 5 only. Means it should not be
less than 3. Because your y is less or equal to x. You are telling that?
Yes.
Okay, then let's say x is equal to 4. Then now again it's not less than, okay, it's less than 2. Okay, but at that case, if I take x is equal to 5, then 5 minus 3 is equal to 2. So this will also not get included. Then which points will be there? How will you get that? So can you draw the line
Ma'am,
x, y?
ma'am, it is too much line, ma'am, infinite line.
Yeah, it's an infinite line and x minus
Sorry,
y
ma'am, infinite points, ma'am.
region. Yeah. X minus y is equal to 2. Just draw this line first.
Ma'am, I think we can have found it by x equal to 2 minus y, like this.
Yeah, that is also one of the thing. Okay, but okay, then okay. First, but the easiest way is to draw this line. Can you draw this line? How will you proceed for the to draw this x minus y is equal to 2?
Yes, ma'am. Put x and y
yes, ma'am.
exactly 0, ma'am.
X and y 0. Then where to put 2?
No, ma'am. Put x is equal to 0 when we got y intercept, or y 0, then we got x intercept, ma'am.
Okay. So whenever your y is 0, let's say somewhere here x is equal to 2 is there. Okay. And see, if you put x is equal to 0, y is equal to minus 2, you will get point somewhere here, and yet then you can draw that line also. But the thing is, I will put x is equal to 5. Is it fine? Because I know the value at this point, x is equal to 5 here. So I will find, okay, once I put x is 5, y is equal to 3. Yeah.
Ma'am, is answer for this question is 16 by 25?
Yes. Okay. So
can we go by graph, ma'am? Easily by triangle.
Yeah, I have to go by graph, I think.
We are going with the graph only. That will be the only easiest path.
Way, yes.
So this is your x is equal to this line is what? X minus y is equal to 2. But we want x minus y should be less than 2. Then just decode which region you required.
Below.
Ma'am, ma'am, towards the origin, ma'am.
for x minus y to be less than 2.
Yes, ma'am. Put x and y is equal to 0. We got the true, ma'am.
Okay.
Then it is true. Then we go ahead with towards origin, ma'am.
We want x minus y should be less than 2.
Yes, ma'am. Put n x and y is equal to 0. Then we got true. Like 0 is
So which part? This one or like
towards origin,
let's
ma'am.
say I will say it a D1 and
Yeah.
I'm
Yeah,
saying
D1,
it
D1.
Okay, everyone is clear with it? So your required region is this one, D1. Fine? The
Yes,
question
ma'am.
is now, how will you calculate the area of D1?
Subtract this D2, ma'am. Half into base into height.
Yeah, great. So area of D2 is
9/2.
half base into height. What's your base? 3. Height 2.
9/2.
Right? Is it fine? Here your point is 5, 3. Right? This point D is 5, 3, is it? And this point is 2, 2, 0. What's the length here? Yeah.
3 and above 3.
Yeah, 3 and 2. Fine. Are you guys okay with
Above
that?
part 3. Above part 3.
So it's a 3 into 2, right? Height into base, can I write? Okay. Area of T2, how will you get it? Half into base into height. What's your base here? The length of
Height
base?
is 3. Ma'am, height is also 3. Base is also 3 and height is also 3.
Yeah. So it will be 3 into 3.
9/2.
Okay. 9/2. But we want area of D1, right? Because our required area is, or I would say it a required area. Is it fine? Area of required region. Or say it D1. That is what? Yeah, that is what. How will you get it? The area of triangle, what it was? OAB, right? Area of triangle OAB minus area of D2. Is it fine? What was area of triangle OAB?
25/2.
So it was 25/2 and this is 9/2. So you got this one as
16/2.
16/2. That means 8. So what will be the probability that x minus y is what? Less than 2. That is nothing but your area of D1 divided by area of triangle OAB. Now, can anyone explain why I am taking this ratio here? Why this is not my answer?
Because this is probability, ma'am.
This is probability, which is the basic formula we are using here. Favorable outcomes divided by all possible outcomes, right?
Yes, ma'am.
This is not any new formula here. This is the basic probability formula. So area of D1 is 8 and area of triangle OAB was what? 25/2, right?
Yes.
25/2, yeah. So
16 by
16
25.
by 25. So that's your probability that unsold milk after 2 days, it's less than 2, right? Less than 2 liters. Any doubt?
No, ma'am. No, ma'am.
Okay, let's move to the next one then. So yeah, you also have the solution here. So yeah, next question is also similar. The joint PDF of two random variable x and y is given as given in front of you, and we have to calculate marginal density of x. So I don't think that this will take too much time, right? Marginal density of x, will you calculate it?
Ma'am,
Yeah.
could you please show me the last previous question answer? Last.
This one?
Yeah. But I have question, ma'am. They have given 2 by 25 is the f of x. I mean, function is
Yes,
xy
yes,
is
yes.
2 by
That's a
25.
PDF.
Yeah. Then that PDF is not considered here. We did not consider.
See, we want area of region OBD, then why will we take the region? So region, we have used the PDF, we have used to declare that our distribution is uniform. See, once you got to know that you have some x and y as a random variable and distribution is like that, and you want to calculate the probability that amount of milk that in short x minus y should be less than 2, right?
Yes.
So once you got this scenario, you will find, okay, I want to calculate x minus y should be less than 2, and this is the given information to me. At that time, you use these limits of y and x and calculated the total area. Okay, just a minute. Yeah, you calculated the total area of the region and also plot your line which is required to you, that is x minus y less than 2. Okay, so out of the region you find out that, okay, this is my region which I wanted to find out the probability of. See, then once you calculated the total area of the triangle, then you found out that then you compared it with your PDF fxy which was given to you. That was 2 by 25 for the given region. Okay, for which
Yes.
you also calculated the area. Then you found out that the PDF is nothing but the 1 upon area you calculated, right? That is 2
Yes.
by 25. So you declared that by observing your joint PDF and the area of your triangle, you got to know that your distribution is uniform.
Okay.
Once you know that your distribution is uniform, in that case only this area kind of things works. Otherwise, it may be possible that, are you able to see this arrow I am hovering here?
Yes, got it.
Once it say this is the region you got from your whatever say limits of x and y, at that time it's not possible, it's not always obvious that probability that x and y taking the values in this particular region and the same area in this particular region will not be equal if your distribution is not uniform. So we used our joint PDF to confirm that the distribution is uniform. Once you confirm that your distribution is uniform, then this area kind of things, what you are doing now, you are doing the calculating this area of this orange shaded region and dividing it with the total area to get the probability that x minus y is less than 2, right? That is work that is giving you the correct answer or is working with your example because of this line, that your PDF is uniform.
Okay.
Okay. So, okay, yeah. So now this is the question, and
if we had x minus y, ma'am, if we had x minus y less than equal to 2,
yes,
then we also have to include that line, right?
Yes.
X minus y equal to 2.
Yes, yes. But since it's a continuous function, I don't think so. If you, even though you include 1 point, x minus 1 point, that means one line. and not create that much difference. Okay, did you guys got this question? Here we want to calculate marginal density of X. So don't worry, this is the second last question, it seems.
Ma'am, there's a Maths 2 session also starting.
Oh, at what time?
8, ma'am.
Okay, all of you have that session.
Yes, ma'am.
Yes, ma'am. Python session, ma'am.
Okay. So, okay, no problem. After this
Ma'am,
question,
can we go through this question and the next question? Can you?
Sorry.
Ma'am, can you explain it instead of we trying first so that we save some time? This and the next question. Quickly, we can complete it. Ma'am.
Marginal density of X, marginal density of Y, and then check whether they are independent or not. And there is one more question. So that's not a problem. If you guys have a lecture at 8, then we can stop it here, and I will share the slides, and we can discuss these things in upcoming sessions.
Ma'am, please discuss this one question. Marginal
Sorry?
density of X.
Yeah.
This one, please finish.
Yeah, sure. So see here. So what's our function? Fxy is (3/2 xy). X is lying between 0 to 2. So what's your deadline for assignment 6?
Tomorrow.
Yes,
ma'am.
Tomorrow.
It's tomorrow. It might be on Friday, right?
No.
No, it's tomorrow.
Okay. X plus y.
Ma'am, for both the week 5 and week 6, deadlines are tomorrow.
Okay. So this is what okay, this is our joint PDF, and we want to calculate marginal density of X. Okay. So what's the marginal density? Generally we give it as integral what? Over the range of y, fxy dy, right? This is what the definition for marginal PDF. Is it? Is it so?
Yes, ma'am.
Okay. Then now you know fxy, but how will you get the limit of y? Because here they said x is lying between 0 to 2, y is 0 to 2, and the region is x plus y less or equal to 2. So it's very sure that you have to draw the graph first. So let's say this is 2, this is again 2. I say somewhere here 2. Okay, and x plus y is equal to 2 is nothing but, okay, x is 2, y is 2. Okay, this is fine. X plus y equal to 2. So less or equal to, that means which one? This part? Right?
Below one?
Yeah, this one. Okay. So now you want to, you are interested in finding the range of y. What's the lower limit? What's the upper limit? Anyone?
Ma'am, lower limit is 0 and upper limit 2 minus x.
Okay. So whenever you want the limits of y, you can draw a vertical strip. Okay, so that you can swap this what we say strip along the x-axis, x lying between 0 to 2. So now you can have this limits will be y is equal to 0 to y is equal to what? This equation is x plus y is equal to 2. So what will be the value for y? Upper limit for y?
Minus x.
2 minus x.
Minus x.
Okay. So now we will integrate it from 0 to 2 minus x. What's our giant PDF? 3 by 2 xy dy. So with respect to y, you have to integrate. So you will first, whatever the constants are there, keep it outside so that it will not confuse you. Is the x constant here?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Right. So just keep it outside so that we do not confuse it. Y dy. Okay. So now integrate. What will you get? 3 by 2x. It's a y square by 2 and the limits are 0 to 2 minus x. So you analyze with the 3 by 2x into 2 minus x whole square divided by 2. So your marginal PDF for x is 3 by 4 x into 2 minus x square. Okay, that is your fx of x. Now similarly, if I ask you for the marginal PDF for y, then it's nothing but integration from the limit of x to fx
0
by
to 2 minus y.
dx. So what will be the limits for here?
0 to
Same,
minus
ma'am,
y.
like 0 to
yeah, 0 to
2 minus x. 2 minus y, ma'am.
Y.
Okay, so like your strip will be horizontal this time. Is it so? See, this is your x plus y is equal to 2. So if I take this is my required region and I will take strip as this. Fine. So the lower limit for x is 0 and upper limit is x plus y is equal to 2. That means x is equal to 2 minus y. Okay. So you will integrate it from 0 to 2 minus y. Rest of the integration, will you try it for so that I will introduce you the next question and discuss it in short.
Yes,
It's
ma'am.
your like. So I will just take your 3 more minutes. That's it. So you just calculate it again ahead, and if calculation mistakes are there, then just take it. As I will share the slide, so you can verify from it. So the next question was about the marginal density of y. And then once you calculate the marginal density of x and y, you can check whether they are independent or not. So just tell me quickly, what's the how will you check whether your marginal PDFs are independent or not?
If joint, if
Conditional
joint are
into
equal to
marginal.
conditional.
Joint equal to conditional to marginal.
Conditional will be like very tricky, but once you know your joint PDF and once you know your marginal PDF, you can just check this whether the marginal product of marginal is equal to joint or not. Okay.
Mm-hmm. Oh, yes, ma'am.
Yes, right.
Conditional PDF is also a thing, but for that you
Yeah,
have
yeah.
to calculate again.
Product of marginal, I think equal to joint, that will be independent.
Yeah.
Hmm.
So now the next question is about you have x and y random variable which are uniformly distributed over the region D, which is y less or equal to twice x, and x is lying between 0 to 1, y is lying between 0 to 2, union another region which is x 1 comma 2 cross 0 comma 2, then find the marginal density of y. So in this particular question, the main task is to draw the diagram, right? Once
Yes,
you have the figure with you, then after that you can integrate the things. So I will just explain you how to draw it. And and you just after that you just try to calculate it. If even though after that if you get any doubt, then you can ask on the discourse. So yeah, you can help me with this question. So your x and y is uniform over D, and D is a set of all the x, y such that y is less or equal to twice x, and x is lying between 0 to 1. Y is ranging between 0 to 2. Union closed interval 1 comma 2 cross 0 comma 2. So first let's graph this part only. Okay, so y is equal to twice x. What should it be? So let's say your x is 1 here and 2 somewhere here. Y is taking 1 somewhere here and 2 somewhere here. Okay, so when your x is equal to 1, what should be the y? Y is equal to twice x, right? We are drawing first y is equal to twice x. So y is equal to twice x will look like, okay, whenever your x is 0, y is 0, right? Whenever your x is 1 by 2, your y will reach to 1. Fine. When your x will reach to 1, your y will be at 2. So your graph will be just like that. Y is equal to twice x. This is not a curve or straight line. Just consider it. Y is equal to twice x. Now another thing is x is lying between 0 to 1 and y is 0 to 2. That means we know these things. Now we want y less or equal to twice x. So which part, upper or lower? Yeah. Lower one. We want.
Ma'am.
Yeah.
This first 1 comma 2 corresponds to x, right? And 0
First we
comma
are
2.
dealing with first we are dealing with this set only. After that we will go towards that. So y less or equal to twice x, that means this lower region, right? So your first required region is this one, this shaded one. Okay, so we are done with the first set. Now let's move to this one. Yeah, so here this first interval is for x, second interval is for y. So 1 to 2, that means it's covering this portion, and also it's covering 0 to 2. That means it's covering this whole rectangle, right? 0 to 2. For y, it's covering 0 to 2. For x, it's covering 1 to 2. That means this rectangle. Is it so? So now your required region is this one, this whole D1 plus D2, both. Okay. Now you need to calculate what marginal density of y. Will you be able to calculate it? So see, whenever you want to calculate marginal density of y, the first thing we can do is, what is Fy of y? Marginal density of y, yeah, anyone? Integral over x, fxy dx, right? But do you know what's your fxy is? It was not given in the question, but in the question it was given that xy was a uniform D. So you know that fx
1 upon area.
1 upon area of what?
The shaded region.
Okay, shaded region. Let's say your shaded region is D1 and D2. Let's say, so your required area is nothing but area of D1 plus area of D2, right? Isn't it? Area of D, let's say. That's actually area of D, right? Because the region D is this one. And here your area of D is nothing but made up of D1 plus D2. What will be the area of D1? Half into base into height, because it's a triangle. D1 is triangle, right? So base is 1, height is 2.
3 units.
Area of D. So half into base into height. Oh, sorry, height.
Total 3 units.
And what about area of D2? It's a 1
2.
into 2. Okay, fine. So it's a 3. Area of D is 3. Okay, now you know your fxy is what? 1 by 3. Okay. So for fy of y, for marginal density, now you need the range of x to integrate over 1 by to integrate for the integrand 1 by 3. So what's your range now?
Y by 2 to 1.
Okay. Yeah. Y by 2 to 1. So
for this triangle part.
For this triangle, even for the whole.
Then for 2 it should be 2. So y by 2 to 2.
Because whenever you draw any strip, it should not drop. Whatever your strip is, that should not get break when you travel it along y. So if you draw the strip like this, and you go like from x is equal to 0 to 2, it will not break. It's not going to break anywhere, right? Sorry, y is equal to 0 to 2. So this can be the limits for your x. So here y is equal to twice x. That means x is equal to pi by 2. This is your lower limit, and upper limit is 2. Right?
Yes.
Are you getting it?
Yes.
So this is one of the example where your lower limit is in variable format. Someone was asking, right, that always upper limit will be in the variable form or not. So this is kind of example where your lower limit is taking value y by 2 and upper limit is 2. And we have to just integrate it. 1 by 3 integral is x, y by 2 to 2. That's nothing but 1 by 3, 2 minus y by 2. Once you solve it, it's a 1 by 3, 4 minus y by 2. So it's a 4 minus y by 6. Okay, that's what the marginal density for y. Okay, is it clear to everyone? So that was all about today's session. If you guys have any doubt, you can tell me. Yeah, here option number 2 is correct. Yeah.
Ma'am.
Yes.
Ma'am, even the last week, that is week 5, solve with a slide is not uploaded.
Yeah, there was a correction, so it's not uploaded. I have. Did you attended that session?
Yes, ma'am.
There was one correction. That's all. Okay. So, thank you for today.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yeah.